Increasing the temperature of a system means the same number of molecules have, on average, more energy, and as a result, more particles are likely to have higher energies than at lower temperatures, shifting the peak of the Maxwell-Boltzmann distribution curve a little to the right and squashing it down slightly. As a result, there will be a higher proportion of molecules with the required activation energy, explaining the high frequency of successful collisions and rates of reactions at higher temperatures. The total area under the curve, however, will always remain the same, as change in temperature doesn't change the number of molecules present. Increasing the concentration of molecules in a system means more molecules in total, and this does increase the area under a Maxwell-Boltzmann distribution curve. If the temperature is the same, however, the average kinetic energy of molecules in the system is also the same, meaning the same distribution of energy and the same shaped curve, just with a larger area underneath. There are now more molecules with the required activation energy, given a higher frequency of successful collisions. However, the proportion of molecules with required activation energy compared to those without remains the same as for a lower concentration. Decreasing the activation energy for a reaction by using a catalyst has no impact on the number of molecules in the system, the area under the curve, or the average kinetic energy of the molecules, the shape of the curve. It does, however, increase the proportion of molecules that have the required activation energy, increasing the frequency of successful collisions and the rate of the reaction.